Good morning, Year 11s. Welcome to Polynomials. This topic has to be fast, so we're going to get to moving quickly. Please take notes, and hopefully these first couple of videos will just be a recap from Year 10. Alright, initially, let's look at null factor law. So null factor law states that if you have a times b equals 0, then a or b must be equal to 0. And we can see that in these types of factorized equations here. So here, I would see that this has two parts. You can call that a and that b. One of them must be equal to 0 in order for the entire thing to be equal to 0. If one of them is 0, it doesn't matter what the other is, it's 0. So here, for what value of x will the a side be equal to 0? Well, x is equal to 0. Here, if x is equal to 7, then 7 take 7 is 0, the b side is equal to 0. So our two solutions are x equals 0 and 7. Now that's quite easy to see. Over here, factorized, again, your a and your b side. You don't have to write that in, but it's just a good way to think about it, to remind you you'll have two solutions. One is quite obviously x equals 3, because 3 take 3, 0 on that side. But this can be harder to see when they look like this. So you just have to remember that you want that side to equal 0. So you want that bit to equal 0, and then you've got a separate little equation you can solve. So take 5 from both sides, divide by 2. X equals minus 5 on 2. So our solutions are x equals 3 and minus 5 on 2. And don't be afraid to go into this separate little equation off to the side in order for you to get that one right. Don't try and, unless you're extremely confident, don't try and shortcut straight from there to there. It's doable, but risky. Alright, what not to do? What not to do is if you see an equation like this, you might think, I'm going to divide both sides by x, which gives us 5x equals 35. Divide both sides by 5, x equals 7. Now, the reason that's what's not to do is because really, this could also be written as 5x squared take 35, x equals 0. We could then factorize 5x out, leaving us with x take 7 equals 0, which is that example up there. And we know that that example up there has two solutions, 0 and 7. Whereas if we divide by x at this stage, we knock out one of the solutions. So don't ever divide by x because you're potentially getting rid of one of the solutions. Instead, the aim of all of these polynomials problems is to get 0 on one side, everything else on the other, factorize and solve. Alright, so that is in fact our general plan. When solving quadratics, say quadratics has an x squared, we get in general form, which makes it look like that, with 0 on the other side. We factorize, and then we find a solution for each factor. Note, it's not always possible to factorize. That'd be nice, but we can't always do it. If we can't factorize, then we look at other options, either completing the square or quadratic formula. Coincidentally, the next two videos. So, now I guess is just remembering how to factorize. And some factorizations are easy. So for example, I would expect you to know that if you saw x squared plus 5x plus 6 equals 0, you could factorize that by thinking, well, there's a 1 at the front, you can have plus times, think sum and product, what adds to 5 multiplies to 6. Adds to 5 multiplies to 6 is 2 and 3, so therefore x plus 2, x plus 3. And you'll have started that in year 9, and then worked on it again in year 10. So when there's a 1 at the front here, sum and product should be nice and easy for you. So therefore x is minus 2 and minus 3. However, it's not always going to be that simple. So take for example here, there's not a 1 at the front. So the question is, well, how do you then solve it? Good news for you, or how do you then factorize it? Good news for you is there are dozens of ways to factorize this. Okay, maybe not dozens, but at least 6. And you can choose one that works for you. If you Google factorizing a non-monic quadratic, non-monic meaning not a 1 there, you'll come up with lots of different ways to do this. But I'm just going to show you one. One way is look at this being A, B, and C. And then I want you to take A and C together. A and C, A times C is 24. And I want you to look at B as well. B is 11. Then it becomes essentially a sum and product problem. We're looking for numbers that multiply to 24 and add to 11. Now, numbers that multiply to 24 and add to 11 for us works out quite nicely. Our numbers are going to be 8 and 3. Okay, and if you're not sure on how to hunt for that effectively, you can't just think of it in the top of your head, don't worry, I'm not expecting you to. One way to do it is take 24 off to one side and start listing factors. So factors of 24 might be 1 and 24, 2 and 12, 4 and 6. What else goes in there? Well, you could be thinking, well, 8 and 3. And as you go down finding factors, you're adding them together in your head, thinking, well, which one of these is going to come close to 11? It's that one, that's our number. Alright, so now we've got this 8 and 3, what do we actually do with it? Well, we what's called split the x term. This entire technique is called splitting the x. This here is the x term. We have x squared, x, and a constant. We're going to split that 11. And what we're going to do is to write this as 2x squared plus 8x plus 3x plus 12 equals 0. Now that sounds odd, but I hope you'd be happy with saying that sorry, someone just knocked on the door. So I hope you'd be happy that that 11x is really the same as that 8x plus 3x. So we've taken the 11x and split it into two parts, which looks like we're making it more complicated. And the reason we're doing this is because then we're going to treat this in halves. So here, this half, we're going to take out a highest common factor, which is 2x, which leaves us with x plus 4. And on this side here, we're going to take out the highest common factor, which is a positive 3, which leaves us with x plus 4. And if we've done this right, those two should be exactly the same. And we can see they are. If you haven't done it right, then they won't be. And that means we can take a factor of x plus 4 out the front. So we're going to remove a factor of x plus 4 because it's common to both. And what we're left with is 2x plus 3 equals 0. Now we're going to continue and do null factor law. So we've got our a side and our b side. So we have x equals minus 4. This is a little harder, so we can take it off to one side. 2x plus 3 equals 0. Take 3 from both sides. 2x equals minus 3 divided by 2. X equals minus 3 on 2. Those are our two solutions. Alright. Here, looks scary, but isn't. We need to get step 1 happening. Convert to standard form with a 0 there. So, let's do that. So expand and simplify. 4x squared plus 20x equals 6x. Take 4x squared, take 3. Then throw everything on one side, 0 on the other. So if we're going everything on one side, we'll have 8x squared here. Adding that. Take 6x from both sides, so plus 14x. Then here, add 3 equals 0. Alright, now we need to be able to factorize that. So once again, we take our a and our b. Sorry, a and our c and our b. A and C is 24. Ooh, that's lucky again. B is 14. So now we're looking for things that multiply to 24 and add to 14. And hopefully you're all thinking, well, it's 2 and 12. Brilliant. So then what we do is we split the x term. 8x squared plus 2x plus 12x plus 3. And note, it wouldn't matter if I wrote 12x and 2x the other way around. This would still work out. Then halves. Highest common factor here is 2x, which would leave us with 4x plus 1. Highest common factor here is 3. So if we take out a positive 3, we have 4x plus 1. Therefore, we keep this equal to 0. Factorize out 4x plus 1. And what's left is 2x plus 3 equals 0. Then we can solve both of those. Take them off into little equations if you want. Or x equals minus 1 on 4. And x equals minus 3 on 2. Alright, two more. So this long video. Here, sometimes we have a fraction. And if we have a fraction with an algebraic denominator, best way to do it is just multiply out that algebraic denominator. So we're going to multiply here both sides by x. 1 equals 3x, take 2x squared. Then we go ahead with our plan to get everything on the left-hand side and 0 on the right. So add 2x squared to both sides. Take 3x, the positive 1 stays there as 0. Now we're looking for a, c, and b. AC is 2, b is minus 3. So what multiplies to 2 and adds to minus 3? Well, if you think about things that multiply to 2, you're probably thinking 1, 2, and that's it. But remember, you've also got the minus 1 and minus 2 option. because minus 1 and minus 2 do multiply to positive 2. Alright, so then we split this minus 3 into minus 1 and minus 2. So 2x squared minus 2x minus x plus 1 equals 0. Alright, once again we're going for diffuse sides here, but this time we might have to be a little bit tactical. Here we can take out our highest common factor of 2x, which would leave us with x minus 1. Now here, it doesn't look like there's any common factor. So really the only common factor is 1 or minus 1. And we can see that in the bracket we had here, there's a positive x at the front, but there is a minus x. So really we're going to take out a minus 1. Sorry, minus 1, bracket. Then what's left in here is going to be a positive x and minus 1. Because if we multiplied that back out, we would get to the step above in that half. Alright, and now we have this common term of x take 1, so we can remove that common term of x take 1, and what we're left with is 2x minus 1. So our solutions are, from this half, x equals 1, and from this half, x equals a half. And you could take that off to one side and solve. Alright, last one, I promise. Now this one looks rather odd, because if you did multiply it out, that would give you an x cubed. And this is where we start straying into higher order polynomials, cubics and quartics, which can have more solutions than just 2. And this is where methods goes. So what you can think about is really this is an extension of the null factor law. There are 2 solutions that could come from here and 1 from here. So really this looks like A, B, C equals 0, then A or B or C must be 0. So our solutions are easier to spot when it's fully factorized. That is quite factorized. Well, it is factorized. This here, we need to factorize more. 2x plus 3. Now, because this is a quadratic with a 1 at the front, we're thinking sum and product. What multiplies to positive 6 and adds to negative 5? X take 2, x take 3. Then our solutions are x equals, from this portion here, minus 3 on 2. From this one here, positive 2. This one here, positive 3. Alright, so we'll practice that more in class. Hopefully that's given you some good notes to work off. Thank you very much.